Okay, so from now in this lecture we will discuss the topic called stack. Okay, so those who are already studied the microprocessor and microcontroller subject already know about this concept. That means what is the stack and what is used and implementation concept. Okay, so in this computer architecture and organization subject, stack is also used in the similar fashion. Now I will discuss the importance of stack, what is the definition of stack, how stack is actually used, and different shortcut instruction that may be used in the stack push and pop operation in this lecture. So first, in the introduction there are 4 points. First point is that a computer program often needs to perform a particular subtask using the familiar subroutine structure. Now in this need of this subroutine structure, stack is actually used. Okay, now the second point is that in order to organize and control an information linkage between the main program and the subroutine, these two are very vital point, main program and the subroutine, a data structure called stack is used. So stack is actually falls in the category of the data structure. It is also used in the C programming also, and also used in your microprocessor or the computer organization. Now whenever in the microprocessor we have written a program is actually a series of instructions written into the main memory. Suppose this is your main memory. I have drawn the main memory structure. This is your memory location, and we have written the different instruction to perform a definite task in the main memory. Okay, so this is a ordinary structure program. So this is your main memory. This is your main memory. Okay, and we have already assumed that we have written a program in the main memory to perform, suppose, the addition of the two number. Now just like in your C program, we have a concept that is called the function. That means whenever a repetitive task have to be performed several times, then we have written the program, another location from the main memory that has to be called into the main program several times. That is the actually the function of the function in the C program. But here just the substitution of the function, just like in a C program, here we have used the subroutine. Okay, that means you may call that it is similar to a function in a program, high level language program. Okay, so subroutine is not actually written into the main memory. This is your main memory where the program is actually written, or the space reserved for writing the main program. Okay, and subroutine is a series also. This is also the series of instruction or a program to perform obviously some definite tasks, but that is written different memory location from the main memory. And also the purpose of the subroutine is that that function may be required several times into the main program. That's why it has not been written into the main program, but it has written somewhere other than memory location of the main program, and it has been called whenever required this subroutine program. Suppose in the addition program, if the carry flag is generated, then we want to perform another small program to be run, then this carry flag, if the carry flag is set into the main program, the program execution or the program control will be shifted to the subroutine, and to the after performing the subroutine program, the control of the program is actually back to your main memory, and next instruction also to be executed one by one. So to perform this concept, stack is actually used. So stack is actually linkage to the subroutine concept. Okay, and also the important point is that the subroutine is not written into the main memory. It is written into another part of the computer that is reserved for the stack. So subroutine is actually written onto the stack memory. Okay, that is separated from the main memory. Actually stack, to implement the stack concept, a different memory location of definite size is to be preserved or saved where the subroutine program is written. So that is the concept of the subroutine, and it is very much similar to the high level function concept. Okay, this is the definition of a stack. stack is the list of data element. Now what is stack? After discussing that, now we have to discuss what is stack. Stack is the list of data element, usually words or bytes, with accessing restriction that elements can be added or removed at one end of the list only. This end is called the top of the stack and the other end is called the bottom. The meaning of this definition is that, and the structure is sometimes also called the push down stack. Okay, so the meaning of is that the definition of the stack is a obviously the collection of data, that is called the stack. But unlike the main memory, this is, suppose this is your stack, okay, and also the number has to be added into the stack, just like suppose this is your bunch of memory location and you want to add some memory location, and it is, suppose this is your stack. So stack is implemented is a push down approach. Push down approach means, suppose this number has been added into the stack 1, next number is added 2, next number is 3, like that. So number has been pushed into the memory like that. So next we want to add 4, 5, like that. And also the meaning of that, it has accessing restriction. Accessing restriction, that means that suppose all the number 1, 2, 3, 4, 5 have been added into the stack, just like your push down approach. Push down approach means, I am again repeating, suppose first element is added 1, after that upon that 2 is been added, upon that 3, 4, 5, like that also. Then the meaning of the accessing restriction is that you cannot access, suppose we want to access after inserting all the element into the stack, we want to access 2, okay, so you cannot access 2. This is the accessing restriction. That means the last element inserted into the stack, that is the first element to be accessed into the stack. That is the main concept into the stack. You cannot access any arbitrary memory location content from the stack. That is the meaning of the accessing restriction of the elements, okay. And whenever the last element is inserted into the stack, that is called the top of the stack, and the first element that has been inserted into the stack, that is called the bottom element. So this is the bottom element of the stack, okay. So this is your bottom element of your stack and this is your top element of your stack. And also to accessing way of the stack element is that you have to first access this 5, then 4, then 3, then 2, then 1, like that. So whenever whatever element is inserted into the stack last, that has to be accessed first. So that is the concept called last in first out. That means the last element to be inserted into the stack, that is the last in, and this is the first element that has to be out of the stack. That is the main concept behind the stack, okay. So overall meaning of that, the stack is a concept or a collection of elements, okay, or the collection of words or bytes, whatever you may be said, and it may be the used for the storage of elements or maybe the storage of the series of instruction, that is called the subroutine. It may be used to store the subroutine program or it may be used to store the different data that will be required into the main memory, okay. And also it has not been, stack is not the main memory location, it has been memory location which is separated or isolated other than the main memory. That is the two important concept of the main memory stack, okay. And that is the last in first out, that is the concept of the stack, that the last element to be inserted or the first element to be out of the stack, okay. Next slide. So this is the next slide, introduction continued. 1 minute. Okay. So stack is a collection of register organized in such a manner. Register means, register is just nothing but a memory location. So I have already said in the last class is that the stack is just a memory location, series of memory location that is situated or isolated other than the main memory. That has been written here, that the stack is a collection of register. Register is nothing but a memory location. Okay, organized in such a manner that the last item written into first available to the read. That is the meaning of the last in first out. I have already discussed that. Okay, so stack, and the second point is the stack is a last in first out memory buffer or the LIFO buffer. LIFO buffer means, that means the last element to be inserted becomes the top element, and the first element to be inserted, that is become the bottom element. Okay, so that is the last in first out concept. Third point is that stack allows all read and write operation to be carried out through one end here, and the information that goes into the last come out first. So that has been already, I have said that in the stack you cannot access the content of the stack or the content of that memory location, special memory location, randomly. That means if we want the data after inserting all these 6 elements, suppose we want the data to suppose we want the data to be accessed immediately, that we cannot perform. That is the restriction of the accessing the data. That has not been into the main memory. Main memory, whatever data we want to access, that we can access with the help of the memory location. But here into the stack, just by typing the memory location, you cannot access the content of that address. Okay, you have to access the memory location from the top one by one. After performing or accessing 6, 5, 4, 3, then only you can access the 2. You cannot access the 2 just immediately whenever you require that. Okay, so that is the meaning of that the stack allows all read and write operation to be carried out through one end. Through one end means from that end. From that end you can only access the memory or the content of the stack location, and from that end you can only enter the content to the stack. So that is the two end, that is to be read operation and that is to be write operation from the stack. So when the information is written to the top of the stack, the operation is called push. So whenever we insert this first element here, so that is called the push operation. And if we want, after inserting all the 6 elements, if we want to retrieve the last element, so obviously the last element is you can only retrieve the last element. That is the restriction of the stack. So whenever the retrieve operation is performed, that is called technically pop. So push or pop, the two term that is associated with the stack. Push is means you are inserting the element into the stack, and pop is mean you are retrieving or accessing the element from the stack. Okay, so that is the meaning of this two term. Okay, next. One minute. So this is a pictorial representation of how elements are actually pushed and popped out of the stack. I have already said that, but this is, you can see the pictorial representation. In the pictorial representation you can see that this element is pushed into the stack. This is the first element. So this is the, suppose this is the first element pushed into the stack 1, and this is the second element 2. This is the content. Okay, this is 4, suppose this is 5, and this is 6. So the operation performed by the series of operation performed into the stack is, thus this is the first element that has been pushed into the stack. Okay, after that this is the element to be pushed into the stack. After that this is 3, then this is 4, this is 5. So that means arrow has been, when inserts operation or the push operation is performed into the stack, the arrow has been shown like that. Then after performing all of the push operation, the stack is actually literally full. There is no memory location left to be pushed operation. Then you cannot add further element to the stack, as all the memory location available for the stack is filled up. So then only you can only access the element or get the element. But the restriction, I have already said, the restriction is that you cannot access the random memory location address from the stack. Suppose you want the address 4, after inserting all the element you require 4, you cannot get that. You first get only so after inserting all the element, this is become the bottom of the stack, and this is the top of the stack. Okay, this is also represented by stack pointer. Then that term we will discuss later, but first you will just learn that after inserting all the element into the stack, this is become the bottom of the stack and this is become the top of the stack. Okay, TOS, top of the stack. You will actually encounter this TOS in your different instruction. Okay, so then after inserting all the elements, the accessing becomes from the top. Accessing becomes from the top means first one can only access the 6 to another memory location, whatever he wants. But first and only this 6, the element 6 is can be accessed. After the element, and that operation is called the pop operation. So accessing the element is actually done from here. Okay, then this 5, then you can only access 4. So for the whenever you want to access the 4, then you have to go like this way. So you have to, whenever you implementing the concept stack, okay, whenever you have implemented the concept stack, you first must remember, before implementation, you first remember that how you can access the element, or when you can require the element. So if you require the element 4 first, then you have to insert the 4. You have to design the stack program in such a way that you have to insert the 4 into the stack at the last. Then only whenever after performing or inserting all the elements, if you require 4, then only you can get it at first. Okay, so before implementation concept or the any implementation of the concept in your main program into the stack, that means stack is not into the main program, it is written into auxiliary memory location. So before implementation of the stack or storing the element into the stack, you first keep your mind that how you pop the element. That is the first criteria. Okay, so if you don't consider in your program, then you just can get the elements whenever you require that. That is the concept behind the stack. Okay, so next is slide number 4. Okay, so the stack implementation. So stack implementation in modern computer, stack is implemented by using a portion of the main memory for this purpose. Once the processor register called the stack pointer, so this is your stack pointer, okay, is used to point to the particular stack structure called the processor stack, whose used to be explained shortly. So the meaning of this sentence is that in the modern processor, what happens is that I have said that this is your main memory and this is your auxiliary memory, where stack concept is actually used. But into the modern processor, the main memory, a portion of the main memory, suppose this is your portion of the main memory, this is reserved, this is actually reserved. You cannot write anything into the other than stack concept. Okay, so this has been already stated into the datasheet of the computer that this location, this series of location into the main memory has been kept reserved for the stack. Okay, and also the top of the stack, whatever I have said in the earlier slide, that the top of the stack, that top of the stack is not the technical word, it is technically called the stack pointer. So short meaning of stack pointer is that SP. So whenever you have been pushed, suppose you have pushed number 1 here, so this is pointing, the stack pointer is actually pointing to this memory location content. Okay, or the stack pointer is actually a memory address, it is holding the memory address. Suppose this one address is suppose this is your 50 memory address. Okay, so stack pointer is actually pointing to memory address 50. So that whatever the top, suppose after that you have been pushed into the stack the number 2, you have pushed the number 2 into the stack, and also this address is, suppose this address is 49. So stack pointer is actually incremented by 1 and it has become this, sorry, decremented by 1 and it has become 49. So whenever stack pointer is always pointing to the top of the stack. So that is the meaning of the top of the stack or the stack pointer, whenever whatever you call it, but that is the meaning of that. It is always pointing to the top element of the top address of the stack. Data can be stored into the stack with successive elements occupying the successive memory location. Assume that the first element is bottom, and the whenever new element are pushed onto the stack, they are placed in the successive lower address location. So meaning of that, in the main memory, suppose this is your main memory location, this is your 0 and this is your 39 memory address. Suppose you want to push any data into the main memory, so this is your main memory. Suppose you want to push the data, this is your 35 memory location, so you want to push the data 8 into the 35 memory location first. So that is possible into the main memory, okay, just by written some kind of instruction. But what happens in the case of the stack? Suppose you want to, this is your first memory address of the stack 40 and the last memory address is 50, okay. So suppose you want to push 40, this is your 41. Suppose you want to push some data into the 41 memory location first, so that is not possible. You have to go the successive memory location of the successive element insertion process. That means first you have to insert the data at the 50 memory location, then after like that. You cannot add whatever you want into the stack memory. In the stack memory location you cannot add and retrieve the element according to your wish. You have to go into the stack concept, okay. So last point is that we use a stack that grows in direction of decreasing memory address in our discussion, because this is a common practice. So the first, this is your decreasing, means the memory address has been, whenever the new element has to be pushed into the stack, the memory address is decreased. This is the common practice, okay. And whenever data is retrieved, the stack pointer is actually incremented. So whenever we perform the push operation, the meaning of that sentence is that whenever we perform push operation, then our stack pointer is actually decremented by 1, or if the according to the word length it depends. Suppose this is your 8-bit address, I have data is 8-bit, okay. Suppose I have performed the data is 8-bit, so the stack pointer is decremented by 1, and whenever we perform the pop operation, then the stack pointer is incremented by 1. So that's all for today. We will also discuss the other concept of the stack in your next class. Thank you.